Hello everyone, welcome to my channel. In this video, we will discuss the equation for the maximum and minimum velocity of a car on a banked road. We will discuss three cases: velocity of a car without friction, maximum velocity of a car with friction, and minimum velocity of a car with friction. In the first case, a car with mass m is moving on a banked road without friction at an angle of inclination, theta, with a velocity of v. There are two main forces acting on the car. The first is the gravitational force mg, which acts vertically downwards. The second is the centrifugal force mv squared by r, which is acting radially outwards. The condition for a stable velocity of the car is that the inward and the outward forces along the banked road should be equal. If there is an imbalance in the inward and the outward forces, then the car will skid towards the greater force. We would need to figure out the outward and inward forces acting on the car. For this, we would need to take the components of the main forces acting in those directions. We can use a free body diagram to represent the various components of the forces in different directions. What we notice is that these two are vertically opposite angles and hence are equal. Further, this angle is a right angle with one portion with theta angle. The remaining angle is 90 minus theta. So, the complementary angle in that triangle must be theta. Now, by figuring out the cosine and sine components of the main forces, we get all the parallel and perpendicular components to the banked road. Then, by representing the forces with respect to the car, we can see that the outward force is the cos component of the centrifugal force, the inward force is the sine component of the gravitational force. The components which are perpendicular to the road are of no significance as there is no frictional force. So, equating the inward and the outward forces and simplifying them for velocity would give the required equation for the stable velocity of a car moving on a frictionless banked road inclined at an angle theta. In the second case, the road has friction with a coefficient of static friction, mu. The limiting frictional force is given by mu times the normal force acting on the car. This frictional force acts as a balancing force. If the car tends to move outward, then the frictional force would act inward, and if the car tends to move inward, then the frictional force will act outward. We would need to find the maximum velocity with which a car can travel on this road without slipping, and the condition for this is that the outward force is equal to the inward force. But, in this case, we have to take into account the frictional force as well. Since the velocity is maximum, the centrifugal force will be maximum, and the car tends to skid outward, which is prevented by the frictional force which acts inward. The frictional force component, which is the coefficient of friction times the perpendicular force, adds to the already existing inward force component. Now, taking the condition inward force is equal to the outward force and simplifying it will give the equation for the maximum velocity of the car on a banked road with friction and inclined at an angle theta. In the third case, we will have the same frictional force, but since we are looking for minimum velocity, the inward gravitational force component will be maximum, and the car will tend to skid inward, and to balance that, the frictional force will act outward along with the other components. If we now equate the outward and inward force and simplify it to get the equation for velocity, we would get the equation for the minimum velocity of the car on a banked road with friction, with an angle of inclination theta. There you have it. An easy and simple way to derive the equations for the velocity of a car on a banked road. If you liked the video, do give it a thumbs up and share it with your friends and subscribe for more concepts like these. Happy learning!